Imagine standing on a grassy hilltop in the very early 1800s and looking out over the vast landscape that stretched toward a hazy blue horizon. For as long as humans had existed on this earth, that horizon was not just a visual boundary, but a physical wall. If you wanted to move something heavy across that space, you were entirely reliant on the slow, rhythmic, and often agonizing plodding of an ox or a horse. If the roads were muddy, which they almost always were after a simple rain, your journey simply stopped. This was a world defined by deep, quiet isolation, where the vast majority of people lived and died within a few miles of the exact spot where they were born. Speed was strictly limited by the endurance of biological muscle and the fragile quality of a dirt path. But underneath the ground, tucked away in the dark, damp tunnels of coal mines, a different kind of logic was starting to take shape. Miners had already figured out that heavy carts moved with surprising ease if they rolled on narrow wooden or iron rails. It was a simple trick intended to reduce friction, but for a long time it stayed hidden away in the dark. Nobody realized yet that those humble tracks in the mines were about to break the world open and change the meaning of distance forever. The problem before the railway revolution was essentially one of friction and power. Water was the only real highway that could move goods in bulk, which is why most of the great cities of history sat on the banks of rivers or along the rocky coasts. If you lived inland, away from the water, you were at the mercy of the weather and the terrain. A heavy rain could turn a vital trade route into an impassable swamp for weeks at a time. Moving essential goods like coal, grain, or iron across the land was so expensive and required so much animal power that it often was not worth doing at all. This was the fundamental bottleneck of the early industrial age. Factories could build incredible machines and produce goods at a massive scale using the power of steam, but they had no reliable way to get those goods out to the people who needed them. The world was full of potential energy and new ideas, but everything was stuck in place. There was a desperate, growing need for a system that could ignore the mud, carry thousands of tons of material, and move faster than a galloping horse without ever growing tired or needing to rest. The breakthrough did not happen all at once in a single moment of inspiration. It was a slow, difficult marriage between the stationary steam engine and the iron rail. Early inventors began to experiment with putting high-pressure steam engines on wheels to see if they could move themselves, but the early versions were heavy, clumsy, and prone to breaking the very tracks they sat on. They were loud, fire-spitting monsters that terrified the public and often failed to perform. The turning point arrived when engineers finally realized that the track and the train had to be designed as a single integrated system rather than two separate inventions. By 1830, the opening of the first major intercity line proved to the world that this was not just a gimmick for moving coal in a mine. It was a revolutionary way to move people and ideas across the face of the earth. Suddenly, a trip that once took a full, exhausting day by stagecoach could be done in a couple of hours. The sensation was both terrifying and exhilarating for people who had never in their lives moved faster than 10 miles per hour. They described the landscape blurring past the windows like a strange, shifting dream. But as this new technology began to explode across the countryside, a new and much more invisible problem began to emerge from the chaos of progress. As different independent companies started building their own lines to connect various cities, they all had different ideas about how wide the track should be. This distance between the rails is what we call the gauge. One engineer might think a narrow track was cheaper and easier to wind through steep hills and tight valleys, while another might insist that a much wider track was absolutely necessary for high speed and mechanical stability. In the beginning, this did not seem to matter much, because most railways were small, local affairs. They were like isolated islands of technology that did not touch each other. But as the iron web grew and the lines began to stretch further across the map, these islands began to collide. This led to the Great Gauge Wars, a massive struggle over technical standards that would decide the fate of entire regional economies and the future of transport. Imagine you are a passenger traveling across the country during this era of confusion. You are sitting comfortably in your wooden carriage, enjoying the unprecedented speed, when suddenly the train pulls into a station and everyone is told to get out. You look ahead and see that the tracks change. The rails are suddenly much wider than the ones you just traveled on. Because of this slight difference in measurement, your train cannot continue. Every single person has to move their own luggage, and every ton of coal, grain, or iron has to be shoveled or carried by hand from one wagon to another. This was the frustrating reality of a world without standards. It was a massive waste of time and money, a literal physical barrier to progress that stood in the way of a truly unified nation. The fight over which gauge would become the standard was fierce and filled with ego. On one side, you had the proponents of the broad gauge, which offered a much smoother, faster ride and allowed for grander, more powerful locomotives. On the other side was the standard gauge, which was based on the old coal wagon dimensions from the mines. It was narrower and perhaps less impressive to look at, but it had one massive advantage: it was already being used by more companies. The battle was not just about engineering or who had the best design. It was about the invisible power of the network effect. Even if the broader tracks were technically superior and allowed for more comfortable travel, the standard gauge had the advantage of being the most common. In the end, the desperate need for a unified, seamless system outweighed the desire for the best possible technology. Governments eventually had to step in and mandate a single width for the rails to prevent the country from being sliced into incompatible pieces. This decision to standardize changed everything about the way the world functioned. Once a train could run from one end of a country to the other without stopping, the entire economy shifted gears. Small, quiet towns that happened to be located on the main line turned into booming, crowded cities overnight, while older, established towns that were bypassed by the rails began to wither away into obscurity. The railway did not just move things. It completely reorganized where people lived, how they worked, and what they valued. The scale of this revolution was truly staggering. To build these iron networks, humans had to reshape the Earth itself on a level never before imagined. They blasted massive tunnels through solid granite, built towering stone viaducts over deep valleys, and leveled entire forests to make way for the straightest possible paths. It required a level of financial investment and human organization that the world had never seen. This massive effort gave birth to the modern corporation and the complex financial systems we still use today. Stock markets buzzed with the buying and selling of railway shares, and thousands of laborers moved across continents to lay the iron down. It was the first truly global high-tech industry. As the tracks spread, they brought with them a new and mandatory sense of synchronization. For the first time in human history, people needed to know exactly what time it was. Before the trains, every town kept its own local time based on the position of the sun. But a train schedule requires everyone across hundreds of miles to be on the exact same page. The railway forced the world to adopt a single standardized time, effectively shrinking the planet and pulling everyone into a shared rhythm. This revolution also fundamentally changed the human experience of space and time. Before the railway, a journey of 50 miles was a major, exhausting life event that required days of planning and physical hardship. After the railway, it was something you could do for a simple morning commute or a spontaneous weekend trip to see the sea. It democratized the act of travel. It was no longer just the wealthy who could afford to see the world beyond their own tiny village. The working class could now board a train and see mountains or the ocean for the first time in their lives. This led to the birth of modern tourism and a more connected, homogeneous culture. People began to talk and dress more like their neighbors in distant cities because they were no longer isolated by days of travel. The tracks were the original internet, carrying not just physical goods, but the very fabric and ideas of modern society. The ripple effects of the standard gauge and the railway revolution are still with us in the modern age. When you look at a modern high-speed rail line today, The distance between those tracks is often the exact same measurement decided upon by people in the 1800s. We are still riding on the foundations and the technical decisions made by Victorian engineers in top hats. The logic of standardization that they pioneered is the same logic that allows your phone charger to work in a different city, or a steel shipping container to fit perfectly on a ship, a truck, and a train. They proved that the real power of technology is not just in the machine itself, but in the universal system that allows the machine to work everywhere. They taught us that for a breakthrough to truly change the world, it has to be able to connect seamlessly with everything else. The railway was the first great conqueror of distance, but it also created a new and intense kind of pressure. As trains moved faster and more frequently across the landscape, the old ways of sending messages could no longer keep up. You could send a letter on a train, but if two trains were headed toward each other on the same track, you needed to know about it instantly, not in a few hours when the mail arrived. The iron rails had successfully connected the physical world, but now there was a desperate need for something that could move even faster than high-pressure steam. The stage was set for the next great leap in how we coordinate our lives across the miles. Now that the rails have unified the land, the next challenge is to make communication as fast as the blink of an eye. In the next episode, we move forward to 1844 to see how the telegraph and long-distance coordination changed the stakes of human progress. It is the moment when information finally broke free from the speed of travel. If you want to see how the world finally learned to talk to itself across the horizon, stay